Good day everyone, I am Dahilan from E299 BSEd Math 2A class, and for today's video I will be discussing the concepts and existing theorems of square numbers in the field of number theory. Before anything else, let me present to you the objectives for today's video. First, be able to define square numbers. Second, illustrate the existing theorems. So let us define what is a square numbers. It is defined as numbers that is obtained by multiplying an integer by itself. Suppose n is an integer, then the square number of n is n times n or n squared. Usually, square number is a non-negative integer. Even if we square a negative integer, the result will always be positive. So let us have an example of square numbers. The first 20 square numbers are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, 256, 289, 324, and 361, and lastly 400. So it is called square number, hence when you multiply 1 by itself, the answer would be 1, the result would be 1. If you multiply 2 by itself, the answer would be 4. If you multiply 25 to itself, the answer would be 25. If you square 6, the answer would be 36. If you square 9, the answer would be 81, and so on and so forth. Theorem number 1. The square of a number is either divisible by 4 or leaves the remainder 1 when divided by 4. So using the form A is equal to QB plus 1, you will justify that theorem. So example, we have 25. So in the form A is equal to QB plus 1, wherein your A, Q, and 1 or R is already given. So your Q would be always be 4, and your R is either 1 or 0, and all you have to find is your B here, which is defined or which can be defined uniquely depending on the integer that is presented. So in 25, we have 5 squared is equal to 4 times 6 plus 1. So 25 is divisible by 4, and that is equal to 6, and leaves a remainder of 1. 36 also is a square number. So we have multiplying 4 by 9, that leaves the remainder of 0. Or on the other hand, dividing 36 by 4, and the answer or the result is 9. 4,761 is also a square number. I tried bigger number in this case. So when you divide 4,761 by 4, you get 1,190 and leaves a remainder of 1. 225. So if you divide 225 by 4, the answer would be 6 and leaves a remainder of 1. So 625, when you divide by 4, you get 156 and leaves a remainder of 1. 100 is divisible by 4, and the answer would be 20 without any remainder at all. 60,025, when you divide by 4, the answer would be 15,006 and a remainder of 1. These numbers justify the theorem. There are other numbers much more bigger. I've tried it and it satisfies the theorem. Theorem number 2 states that the square of an odd number is of the form 8q plus 1. So 25, we have 8 multiplied by 3 plus 1. So 8 here is your 8 as stated on the theorem, and 1 and 3 here is uniquely defined depending on the integer. 25 is in the form 8q plus 1. So 78 is your Q. 325 squared is equal to 8 times 152 plus 1. 15 squared is equal to 8 times 28 plus 1. 1355 squared is equal to 8 times 229,503 plus 1. So it is bigger number. So 4,567 squared is equal to 8 times 2,607,186 plus 1. And then 25,689 squared is equal to 8 times 82,490,590 plus 1. And lastly, theorem number 3 states that the last digit in the square number must be one of the numbers 0, 1, 4, 5, 6, and 9. So you have example 0, 1, 4, 9. So I've listed here the first 21 square numbers, and as you can see, I highlighted the last digit with the color black, and it states that we have 0, 1, 4, 9. And all of the numbers stated on the theorem is all can be seen in the last digit of these numbers, which justifies the theorem. That's all, and thank you for watching. God bless everyone!